This is the second video over rational functions, and in this video, we're going to take the information that we found in the previous video and plot that on a coordinate plane to see how these functions look graphed. So I'm going to go pretty quickly through finding the x-intercepts, the y-intercept, the holes, the asymptotes. If you need extra help with that, again, there's another video before this that covers how to find all that information. So I'm going to go pretty quickly. Go back and refer to that video if you need help with finding this information. This video is going to concentrate more on how to put that information on the coordinate plane. Okay, the first thing I'm going to do for this function here is I'm going to factor. I always want to check to see if the numerator and denominator have any common factors. So I can pull out a GCF of 4 from the terms of the numerator, and I do not have any common factors. So just had to check just to make sure. Okay, so here we go. To find the x-intercepts are the zeros of the numerator, assuming that there are no common factors. So we don't have any common factors in the numerator and denominator. So I'm going to set the numerator equal to 0, and I get x equals 2. So I have one x-intercept, and that is the point 2, 0. And I'm going to plot that on my graph here. All right, to find the y-intercept, we find f of 0. So it's going to be 4 times 0 minus 8 over 0 plus 2. That would be negative 8 over 2, which is negative 4. So I have a y-intercept of, excuse me, 0, negative 4. Right there. To find the holes, there are no holes for this one. We're only going to have holes when the numerator and denominator have a common factor. So because I did not find any common factors in the numerator and denominator, we have no holes for this graph. So holes would be none. To find our vertical asymptotes, there's actually just going to be one. We find the zeros of the denominator. And I get x equals negative 2. That's our vertical asymptote. X equals negative 2 is this vertical line here. All along this line, the x coordinate is negative 2. So that's the line x equals negative 2. To find the horizontal asymptote, we have to look at the degrees of the numerator and denominator. They have the same degree. Okay, they both are degree 1. So our horizontal asymptote would be y equals the ratio of the leading coefficient. The leading coefficient of the numerator is 4. The leading coefficient of the denominator is 1. So y equals 4 is our horizontal asymptote. There is no oblique asymptote. If we have a horizontal asymptote, we will not have an oblique asymptote. Oblique asymptotes only occur when the degree of the numerator is 1 greater than the degree of the denominator. Okay, so we have found all of the information that we need, or that's been asked. We are going to do a little bit more here to help us to figure out what the curves are going to look like for this rational function. Now, I do have 2 points already. I've got the x-intercept and the y-intercept, but it would be nice to get a few more points to get an idea of what this curve looks like. So I would like to know, so I know that this curve is going to approach but not tetracross the asymptotes. Now it is possible for it is possible to cross a horizontal asymptote, but that's not something that we're going to see in this class. And depending on how picky your instructor is. And for me, you know, if a student drew a curve through these 2 points, I would be fine with that. But it would be nice to have maybe a third point below the horizontal asymptote and to the right of the vertical asymptote. So I'm going to pick an X value over here, maybe like 3 or 4 or 5 or 6, or, you know, some X value over here, and I'm going to plug it into the function. How about 6? Okay, so I'm just going to find f of 6. So to find f of 6, I'm going to plug 6 in for x. And I get 24 minus 8, which is 16, and then over 8. So I get 16 over 8, which is 2. Since f of 6 equals 2, what that means is that the point 6, 2 is on the graph of the function. So I've just found a third point, 6, 2, and excuse me, I'm sorry about that. And so now I feel like I have a better idea of what this curve is going to look like. Okay, so let's see. I'm on a computer here. Let's see if I can draw this through these 3 points. Okay. And well, you know what? Let me try that one more time. Let's see if it'll erase the whole. There we go. Okay, I'm gonna try this one more time because I want it to look like it's approaching but not touching or crossing that asymptote. Okay, so yeah, this might look a little bit better. All right, it's very hard to draw this on a computer. All right, so I've got my curve over here. My curve is touching, or not touching, I'm sorry, it's approaching but not touching or crossing those asymptotes. It goes through the 3 points, and so I've got a good idea of what the graph is doing to the right of that vertical asymptote. Okay, but there's, you know, something else going on over here as well to the left of that vertical asymptote. And we got to figure out, you know, what's going on over here. I definitely know that there's not a curve above the horizontal asymptote and to the right of the vertical asymptote because this is a function. And if it's a function, it's going to pass the vertical line test. So I definitely know that there is, excuse me, there's no curve above the horizontal asymptote and to the right of the vertical one. Okay, but what's going on over here? Let's find out. So I need to pick an X value somewhere over here, and I want to see what I get as a Y value so I know, you know, what's going on, you know, to the left of the vertical asymptote. So maybe I'll pick negative 6. I don't know. I picked 6, maybe negative 6. So I've got 4 times negative 6 minus 8 over negative 6 plus 2. So that would be negative 24 minus 8, which would be negative 32. And then negative 32 over negative 4 would be 8. So that tells me that the point negative 6, 8 is on the graph of this function. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. So there's a point up here. Wow, that doesn't look round at all. Let me see if I can get that to look a little bit better. Okay, so 3, 4, 5, 6, 8. All right, up here. All right, so that at least tells me that the graph is in the upper left-hand corner. I could find some more points. Like I could plug in negative 3 for X, or I could plug in negative 4. Let me get an idea of what this curve looks like. You know, again, I'm not very picky as an instructor, so if a student found this point and they would sketch a curve up here, that would be good enough for me. But, you know, if your instructor wants to see more points, we can definitely go find those other points. So maybe I'll plug in negative 4 and see what I get. So let's see, negative 16 minus 8 is negative 24 over negative 2, so that's 12. That means the point negative 4, 12. Whoa. Sorry about that. Anyway, the point -412 is on the graph. All right, so, okay, come on. -412. -412 is off my graph, though. It would be, you know, it's kind of be way up here somewhere. It's up here. Maybe we could plug in -8. Okay, I'm just, you know, again, it's probably not necessary to find this many points. Okay, let's see what we get by plugging in -8. Plugging in -8 would give us -40 over -6. So that's going to be a decimal, but that's okay. Let's see, so that would be 6 and 4 over 6, so 6 2/3. So 6.6 repeating. So that was -8. So -8, 6.6 repeating. Okay, so -8, 1, 2, 3, 4, 5, 6. And so, but 0.6 repeating. Okay, so we can see that the curve is up here. It's a little hard to see because our graph isn't all that big. Maybe I'll extend my asymptotes. Okay, so we've got a curve. Let's get up here again. Got a curve here. It's going to look something like this. And so, again, the curve is going to approach but not touch or cross those asymptotes. So I'm trying to draw it to where it looks like it's approaching but not touching or crossing. I'll just say one more time that, you know, kind of it's up to your instructor on how many points you need to plot. You know, 1 point would have been enough for me over here to determine that the curve is going to be above the horizontal asymptote and to the left of the vertical asymptote. But depending on how picky your instructor is, perhaps you might have to find some more points. Ooh, these are fun. Okay, let's do another one. Okay, so the numerator and denominator do not have any common factors. And then to find the x-intercepts, we find the zeros of the numerator. The numerator has no zeros. If I were going to try to set the numerator equal to 0, I get a statement that is not true. 4 does not equal 0. That doesn't make sense there. So what this means is there are no x-intercepts. We don't have any zeros of the numerator, so no x-intercepts. To find the y-intercept, we find f of 0. F of 0 would be 4/3. So our y-intercept is 0, 4/3. 0, 4/3 would be just a little past 0, 1. And maybe right there. Okay, to find our wholes, we look to see what common factors the numerator and denominator have, and they don't have any common factors. So once again, there are no wholes. Vertical asymptotes, we find the zeros of the denominator. X equals -3. This is our vertical asymptote. Okay, horizontal asymptote is y equals 0. This is because the degree of the numerator is smaller than the degree of the denominator. The degree of the numerator is 0 because we do not have a variable. The degree of the denominator is 1. Anytime the degree of your denominator is the degree of your denominator is larger than the numerator, then y equals 0 will be a horizontal asymptote. Okay, you probably can see now why we do not have an x-intercept. We have an asymptote along the x-axis. Oblique asymptote would be none. If we have a horizontal asymptote, you will not have an oblique asymptote. All right, now we want to maybe possibly get a few more points. I can tell that the curve must be up here because I have a point up there. So I must have a curve up here. But if you'd like, you can find a few more points. Maybe I'll find f of -1. So f of -1 is 4 over -1 plus 3. That would be 4 over 2, which is 2. That means that the point -1, 2 is on our graph. Maybe I'll pick an x over here. Maybe I'll find f of 1 or 2. It's just going to keep getting smaller and smaller. Maybe I'll show you f of 2. So f of 2 would be 4 over 2 plus 3. That would be 4 over 5. So that means that the point 2, 4/5 is on the graph. So 2 4/5 would be like not quite, 4/5 is the same thing as 0.8. So that's probably enough to kind of see the shape of the curve. Okay, so I'm drawing my curve. I'm approaching but not touching or crossing those asymptotes. Okay, but I also, once again, need to know what's going on over here. Oops, didn't mean to do that. So we want to know what's going on over here. So we're going to have to pick some x values to the left of -3 because this is the line x equals -3. I want to know what's going on over here. So I'm going to want to pick some x values that are smaller than -3. So maybe I'll pick -4. -4 would be 4 over -4 plus 3. That would be 4 over -1, which is -4. This means that the point -4, -4 is on the graph. So -4, 1, 2, 3, 4. Really, just that one point is enough to know that the curve is going to be down here. But if you want a nice, really accurate graph, you may want to find, let's find at least one more point. How about f of -7? That would be 4 over -7 plus 3, which would be 4 over -4, which is -1. This means that the point -7, -1 is on our graph. So here's -7, -1. Okay, that's good enough to show us that our curve is going to look like this. Okay, now these numbers that I'm picking, you really can pick whatever you like. You know, I just kind of wanted to see how these curves looked, so I'm picking numbers to plug in, but it's really not, you know, I'm not doing anything special over here, picking any special numbers. Now, I guess I sort of am. I was kind of looking at the function, trying to pick numbers that would give me an integer over here, but fractions are okay as well. So, okay, let's look at another one. I've got even a fourth one. We'll see how. I think we could do 4. Let's do this one, and then we'll do one more after this. Okay, this one. I do not have any common factors again. And my denominator does factor. It's the difference of squares. It factors as x plus 2 times the quantity x minus 2. To find my x-intercepts, I need to find the zeros of the numerator. And so I'm going to set x squared equal to 0. This means x equals 0. So our x-intercept is 0, 0. To find my y-intercept, I'm going to find f of 0. F of 0 would be 0 squared over 0 squared minus 4, which is 0 over negative 4, which is 0. Shouldn't be a surprise that our y-intercept is 0, 0, because that's what our x-intercept was, and that's where the two axes cross. And so if the x-intercept is 0, 0, so is the y-intercept. Okay, to find holes, we don't have any again. We are going to see a hole in the last one. So holes would be none. We don't have any holes because we don't have any common factors in the numerator and denominator. Vertical asymptotes, there are two, x equals -2 and x equals 2. We find our vertical asymptotes by finding the zeros of the denominator. And so we've got 2 of them this time. Here's x equals 2, and here is x equals -2. And then we do have a horizontal asymptote. It's y equals, and I'm going to do the ratio of the leading coefficients. The leading coefficients are both 1. And so y equals 1 over 1 or y equals 1 is our horizontal asymptote. Okay, so we need to know, oblique, sorry, let me mention, there's no oblique asymptote. Okay, so we need to figure out what's going on in between the vertical asymptotes, what's going on to the right of this one, what's going on to the left of this one. I know I'll never have a curve one on top of the other because this is a function, but I am going to plug in some values for x to kind of get an idea of what this graph is going to look like. So first, maybe I'll plug in f of 1. So I'll plug 1 in for x. So this one would be 1 squared, which is 1, over 1 minus 4. So this is 1 over -3, which is -1/3. This means that the point 1, -1/3 is on the graph. 1, -1/3 would be kind of like right here. Let's find f of -1. F of -1 is going to be exactly the same thing. This is because we're squaring, and when you square a negative number, you get a positive. So plugging in -1 gives us exactly the same thing as when we plugged in a positive 1. So it's going to be over here. You know, you could verify this by picking a couple more points. You could even pick like 1/2. You could pick 3/2. But it does look like that we've got a parabola in between the 2 vertical asymptotes, because I've got, you know, it doesn't matter. I'm always going to have a matching point, if that makes sense. So if I plug in 3/2, I'm going to get the same thing as when I plug in -3/2. If I plug in 0.75, I'm going to get the same thing when I plug in -0.75. So it does look like there is a parabola in between the vertical asymptotes. Okay, but what is going on to the left and right of these vertical asymptotes? So maybe I'll plug in 3 or 4. It doesn't really matter. How about 3? When I plug in 3, I get 9 over 9 minus 4. This would be 9 over 5. 9 over 5 is the same thing as 1.8. So almost 2. So 3, 1.8. Be up here. You know what? If I plug in -3, I'm going to get the same thing. I'm going to get that 1.8 again. So this is where I can show you. I mean, right away I can. Supposed to go to that point. I can see that the curve is going to be up above. Wow, that didn't look very good. Let me see. It's pretty hard to do this on a computer. See if I can delete that. Delete. There we go. But anyway, 1 point is enough to determine where these other curves are. Sorry, I'm trying not to touch that asymptote. Oh, well. Anyway, I'm supposed to approach but not touch or cross. But by just finding those 2 points, I'm able to see that the curves are above that horizontal asymptote there. Okay, one more. This one's going to have a hole, finally. We'll see what the looks like with a hole. Okay, first thing I'm going to do is I'm going to factor and do this pretty quickly. The numerator factors as x plus 3 times the quantity x minus 2. The denominator is the difference of squares that factors as x plus 3 times the quantity x minus 3. And cancel that, cancel that. So our reduced function is x minus 2 over x minus 3. To find the x-intercepts, we find the zeros of the numerator of the reduced function. And so we have one x-intercept at 2, 0. So 2, 0 is our x-intercept. To find the y-intercept, we find f of 0. You can use the reduced function, or you can use the original. Either way, you're going to get the same answer. I'm getting negative 2 over negative 3, which is 2/3. Negative divided by a negative is positive. Put that right there. There is a hole. We do have a hole. The hole occurs at negative 3. That's our x coordinate of the hole. I can tell that because if you look at the common factor that we canceled, it was x plus 3. So if you set x plus 3 equal to 0, you get negative 3. Now the y coordinate of the hole is found by plugging negative 3 into the reduced function. And I get negative 5 over negative 6, which is 5 over 6. So we have a hole at negative 3, 5 over 6. So 1, 2, 3, 5 over 6. Now the hole is plotted as an open circle. That was okay. It's hard to make that open circle again on the computer. So we just kind of, it's literally a hole in the graph. So I plotted the point negative 3, 5 over 6, but instead of plotting it as a solid dot, I'm plotting it as an open circle. Vertical asymptote, we have just one, x equals 3. I looked at my reduced function and I found the 0 of the denominator. So x equals 3 would be this right here, this line. And I also have a horizontal asymptote of y equals 1. We have the same degree in the numerator and denominator. Take the ratio of the leading coefficient. You can look at the original function. You could also look at the reduced function. It's going to give you the same answer. No oblique asymptote. All right, let me plot y equals 1. Okay, sorry, it's kind of hard to see because my hole is so close to this asymptote. That hole is under, it's at 5 over 6. All right, so I can see that the graph, oh, okay. Again, it's really hard to do this on a computer. So my graph is approaching but not touching or crossing either of those asymptotes. Sorry if it kind of looks like it does touch. Here's my hole. I've got my intercepts plotted. Over here, I need to figure out what's going on over here. I can pick an x value greater than 3 to see what's going on over here. I could also, let me tell you a little trick too. I could also tell the curve's got to be up here. I can tell that because I only have one x-intercept. If I had a curve down here, then I would have to have a second x-intercept, which I do not. So sometimes you can, and depending again how picky your instructor is, it's just a sketch. So you could just sketch up here, just knowing it's got to be up here since I don't have a second x-intercept. So you're welcome to use that kind of, thinking if you want to use that. Sorry, I can't think of a better word than thinking. Sorry, can't think of the word I want to use. But you could also plug in something like 4, find f of 4. Now I'm going to plug it into the reduced function. You could also plug it into the original function, but you're giving yourself more work because the reduced function is going to be easier to evaluate for x equals 4. So I'm getting 2 over 1, which is 2. So the 0.42, okay, so I wasn't exactly super accurate with my sketch there, so maybe I can erase this and make it a little bit more accurate now that I know that the 0.42 is on the graph. Okay, so we've got something like this then. All right, well, thank you for watching this video. This is really a tough topic. Hopefully these videos were helpful and that you have a little bit better understanding on how to graph rational functions.